bit of information about Alliance Corporation. Alliance Corporation is a solutions aggregator, distribution company specializing in both wireless infrastructure as well as broadband communications and radios. I skipped over the initial overview. We were founded in 1993. Our headquarters are in Mississauga. We've got locations across Ontario or throughout Canada, along with USA and Mexico. We've got over 300 plus people, and we've got a world-class product assortment, including a very, very large inventory. With Alliance, you can expect a personalized expert assistance from industry veterans. So we're not looking at just moving the box. Again, we're in our 20th year of business, and our head office is located in Mississauga. Now, to provide you with some background, we've got two core lines of business. We've got the infrastructure solution side, which you'll be seeing on your screen right now, and that essentially covers everything from tower cables, antennas, you name it. We've got it: lightning protection, grounding systems, power systems, and generators. So we can help you through the whole infrastructure build. We also, sorry, I'm seeing a very large delay here. Our broadband solutions cover a wide range of carrier class products. We partner with manufacturers who are best in class. We afford backhaul and transport systems along with point-to-point, point-to-multi-point, so we can really provide you with a solution set that's going to meet your requirements. We have licensed, unlicensed applications for mesh as well as outdoor Wi-Fi. Alliance, I mentioned, is a solutions aggregator. So we really bring value to our core customer base. Some of the services that we provide are an overall path analysis. We do radio pre-configuration if that's a core requirement. We provide assistance with regard to RF and the overall design and engineering of that RF, including licensing requirements with Industry Canada. We provide installation assistance through our network of certified integrators. We've got, as I mentioned before, a large selection of inventory, so we can meet all of your immediate product needs. We can help with staging and kitting. We can handle the whole logistics and supply chain service to ensure that product is available when you need it, how you need it. And that's Alliance Corporation. Thank you for taking the time to listen to me and my technical glitches. I'm going to ask Rob Pilgrim, who is responsible for corporate and business development along with strategy for ABB Tropos, to come online and provide a little bit of a background on the wireless solutions for mining in association with ABB. Rob?
Thanks, Corinne. So thanks for inviting me to be on the webinar. Let me give you a quick little background. As Corinne had indicated, I run business development and corporate development for Tropos. I've been with the company for 8 years. So I've been with Tropos prior to the acquisition by ABB. And as many of you may know, Tropos, based in Sunnyvale, California, we were acquired by ABB back in June of last year, and they have basically kept us as a whole unit, and we now own the wireless network communication solutions for ABB on a global basis. So some people may know us as Tropos, and some people may recognize ABB. The Tropos product line is the same. Our team is the same. The technology is the same. It's just we have the backing of a global giant in the automation space behind us now. So with that, I'll kind of jump into my presentation. What I'm going to talk about today is wireless communication networks for open pit mining applications. We'll talk a little bit about Tropos and how we help our customers. We'll go through some of the architectural and value propositions, and then we'll finish up with a couple of case study slides on a couple of our customers that we've been working with. And then after that, we can take some questions to take any questions that are asked through the webinar and see if we can address those. So again, thanks to Alliance for inviting us, and with that, let's get going. So over the past decade, Tropos has developed wireless networking technology with the goal of helping our customers solve problems. We have deployments now in over 50 countries around the world. We have over 50 patents specifically for technology in the wireless networking and communications area, and we're continuing to add more and more intellectual property into our product as we move forward. We've earned our customers' trust over the years by not just providing great products, which we do provide great products, but we really help them be successful at what they do. So in other words, really getting their applications up and running, making sure that the team that selects Tropos as the supplier for the wireless communication systems is successful in their project and what they're trying to accomplish within their mine. We stand behind our customers during and after the project because we know that the customer's success is really our success, and it only takes one failure to overcome 100 successes. So what we do is we put a lot of effort into making sure our customers are successful. What Tropos provides, if you're not familiar with our product line, is we provide a high-performance wireless IP network system that provides reliability, flexibility, performance, and security to deliver mission-critical applications in mines or in other industrial settings. From a small single application network to a complex multi-application system, our products are able to scale and adapt to the customer's needs. And of course, we support our customers during and after the deployment, including adding new software features such as security elements and new features such as features that would help in terms of deploying and delivering the applications more reliably. So once you make the investment in the infrastructure, you have the ability to take advantage of upgrades over time through our support structure. There are many applications that are useful in mining operations, and reliable communications is a critical component for pretty much all of them. From field data applications to equipment telemetry and even video surveillance, the list of applications continues to grow probably every year, probably every month at this point, with the idea of enhancing both safety and security in the mining environment, as well as improving productivity. As in the enterprise environment, mines can benefit from having a common high bandwidth network, which can help economically and quickly deliver that growing list of applications when and where they're needed. So it's not just hey, let's put this network in place and cover everything. It's really about being able to deliver the application to the place you need it when you need it and making it reliable. Our customers have found that wireless Ethernet is probably the best choice, especially in the scenario where you're building a network platform to deliver multiple applications. And what we've seen is that's really where the value is added in this model. So the applications are really delivering the value, and the communications network is the means of those applications being able to get to the vehicles, get to the place where they need to be within that mine at the right time. In the past year or two, we've seen specifically mining fleet management applications being the real driver behind mine modernization. And as anybody familiar with mining operations will tell you, mining is a capital-intensive business. We've seen mines continue to push modernization as a way to help cut costs, improve production, improve return on capital, and real-time information to be able to provide that asset health and utilization analysis, not only providing longer-term process benefit, but being able to provide real-time benefits to predict equipment failures or failures within the mining environment itself that would delay productivity or cause unexpected work stoppages due to breakdowns, especially where the vehicles are maybe blocking other traffic or it's hard to get crews in to actually repair the equipment effectively. And from a safety and security perspective, video surveillance has been shown to act as a workforce multiplier, allowing security and safety folks to cover more of the mine with fewer people, and basically provide some real-time situational intelligence in the mine. In addition, real-time safety and location systems help avoid accidents. So we're seeing a number of mines deploying location information for the vehicles so that they think of it as a traffic controller, and they're controlling the vehicles and where they are in the mines, so they understand where their people are, where their vehicles are, and they can make adjustments accordingly. So this particular graphic shows how proper investment in the communications infrastructure, when you're putting in your first application for modernization, can help minimize the incremental capital that you spend as you roll out additional applications, like telemetry or video surveillance. So one way to think about it is you put the initial investments in a broadband enterprise-style communications network for your open pit mine, and you may be doing that for fleet management. And that's what we've seen a fair number of our customers do. It's the first application that they're deploying in many cases. And so they put in a broadband communication system that provides the mobility and the wireless coverage to the vehicles for fleet management. But then once they have that network in place, they're able to add video surveillance, telemetry applications, as well as move toward autonomous operations within the mine in the future without having to reinvest and put in additional wireless network infrastructure every time. So they build a platform that they can deploy those applications on, and that's one of the things that really enhances the return on investment within that mine, is having a network that enables the rollout of those applications cost effectively. So that takes us to, okay, well, what are the functional requirements for a network like that? Well, obviously we see a couple of key points like flexible coverage as being one of the requirements. So what we mean by flexible coverage is the ability to distribute the coverage cost effectively through the mine and to be able to adapt to topology changes, to new dig areas, to changing operations and the way the mine's topography looks, because obviously open pit mines change every day. You need to have a network that can adapt to that change effectively. You have to have reliability and scalability. So the way that we like to think of it as we move toward autonomous mining operations in the future, 99.999% availability has to be, your wireless network has to be available in real time, and it can't have failures, because especially if you're using it for mission critical systems or autonomous operations, you have to have communication to the vehicle. So being able to deal with a rough environment like temperature, shock, vibration, being able to avoid interference or retransmissions because of bad connectivity, having no single point of failure. So what we mean by that is having a distributed intelligence within your radio and communications network, to where if you lose a communications node, you don't lose coverage necessarily throughout the mine or throughout that area. And it has to be scalable, both in cost for the individual devices and scalable in terms of the types of application data you're running over the network. From a security perspective, that's a growing concern in every vertical industry we work in. Obviously in the mining environment, I think in the past a lot of people have not paid that much attention to information technology security, because in a lot of cases they're remote locations, and they practiced a model of security by obscurity in many cases. But what we're seeing is that with a network that's connected to the enterprise and back into data centers, that opens up gaps in security where people, which may not even be anywhere near the mine, have the ability to attack the systems in the mine. So you have to be able to leverage a multi-layer security model multi-application enterprise security system that would protect the assets in the mine just like you're protecting your IT assets at your data center or in your enterprise offices. Mobility is a key functional requirement because, as everybody knows, in the open pit mine, you have a lot of equipment moving around. You have diggers, you have haulers, you have pickup trucks and other things like that moving around within the mine environment, and they don't stay still for very long. So by nature, a mine is a dynamic environment. Having the ability to communicate with those moving vehicles is critical. And then, of course, multi-application support, as I had mentioned before, is the basis for driving high value and high ROI on the applications you're trying to deploy. And that kind of leads us to what the IT network architecture would look like for a mine. And this is a very simplified cloud-type view, but it gives you a decent idea of how the infrastructure can be configured and set up from a logical perspective. Typically, we have a data center which may be on-site or off-site, but would be accessible by the operators within the mine, as well as being able to collect data that would be pushed back to corporate. You would have your mine operations applications, your network management applications, your enterprise service applications, all hosted in those data centers or in a set of distributed data centers, which may be on multiple sites. Those data centers are typically tied together and tied to the field offices through a core IP network, whether it's fiber or point-to-point microwave links, connecting different mine locations or sites back into the core data center infrastructure. And then once you get out to the mine locations, you have field area networks, which are typically point-to-multipoint or mesh-type networks that cover the mines themselves. And they're reaching out and communicating with SCADA endpoints, VoIP phones, safety and security system, telemetry devices, or sub-networks, which may be local wired networks at a in a shack or in a facility that's not the main facility, the operating building on the mine site. So you may have some local wired networks that need to be tied back into the main network within the mine. So all of those tie back together, tie to each other through the field area network, and then can tie up to the data center through the core network. And that's the architecture that we've seen deployed for most of our mining customers. And in a given mine itself, the field area network, this is just a diagram of a mine, and I can't even tell you which customer this is. I have no idea. But as you can see, the little green dots are where they have meshing routers, the fixed infrastructure placed. Obviously, this is very dependent on topography and terrain. And then the ones that have little dots, in them, and I think that's about 1 out of every 10, has a backhaul connection. And in this particular model, I believe they're using point-to-multipoint to tie back in to the central facility. So they're using a point-to-multipoint architecture based on a single tower, shooting down to a couple of the mesh nodes within the mine. And then the mesh nodes are then meshing locally with other mesh nodes to provide both coverage and connectivity back to the central location within the mine, the mining operations center, as well as to the other vehicles if needed for a distributed application. So some people have opened the question up, well, why don't you use just a point-to-multipoint system if you have a tower? Well, in the open pit mines, obviously, as you continue digging down and the mining topography changes, we've seen point-to-multipoint systems by themselves have some specific challenges. You run into shadowing issues because it's not perfect. Depression in the earth are perfectly flat, and you do have shadowing issues when using pure point-to-multipoint. In addition, you tend to have a lack of mobility support when moving throughout the mine using purely a point-to-multipoint architecture. Now, that's not to say that there's not a good place for point-to-multipoint. In fact, the vast majority of our deployments with customers include point-to-multipoint. But it includes it as a means of connecting the mesh, which tends to be deployed within the mine in a much more distributed fashion, as you saw from the other diagram where it's peppered throughout the mine. And that equipment can overcome the shadowing because meshing can make 90-degree turns or can get back into areas by hopping from router to router that you wouldn't be able to get into with a point-to-multipoint system without having to build a new tower or a new base station location. And also, in addition, what we found is the meshing routers can be fixed on infrastructure like light poles or specific poles installed for the mesh. Or we see a lot of our customers leveraging trailers to help them adapt to mining the topology changes that they have in the mine. As they start digging out, they can move equipment around much more effectively. If you look on the picture on the right, you can see a few Tropos routers mounted on extendable towers that utilize the solar panels and battery packs to where they're not even physically connected to power on a permanent basis. They self-power. In addition, mobile routers in the equipment ensure constant connectivity. So in most of our mining environment, they put a Tropos mobile router or a fixed router running in mobile mode on the actual equipment moving around in the mine. That's everything from a drag line to dump trucks, to haulers, to diggers, you name it. It gets installed on that type of equipment. So the routers themselves, the meshing routers themselves, are really a key element to our architecture. They're designed for difficult outdoor environments. You know, we don't just take indoor technology and put it in a hardened case. We write our own operating system software with the goal of providing highly reliable and secure communications architecture that will be that'll be there when you need it. In addition, we build our own radios for that outdoor operating environment. We leverage high transmit power, receive sensitivity, and we couple it with high-performance filtering and protection. And for an outdoor environment, those are key requirements because otherwise you end up having to go out and replace equipment often. Unless it's really designed and built for that type of rugged outdoor environment, that it understands how to deal with interference without having to be manually touched or interfered with by an operator. And needless to say, our gear is very hardened. It's designed to stand up to the tough mining environments, meeting shock and vibration specifications, as well as IP67 weatherproofing. And we've been deployed in mines for 6 or 7 years now. So this is nothing new for us. We design our equipment to deal with that type of environment, and it's built to last. It's sort of a tank, if you would. Some of the mounting examples that we've seen in the field, as you can see, they can be mounted on towers. We have equipment mounted on drag lines. Down below on the left-hand side, you can see another one mounted on a mobile trailer, or on the bottom right, mounted on the undercarriage of a piece of equipment operating within the mine. So the equipment itself gets mounted in all kinds of different places. It's very dependent on the kind of equipment that we have, the way they like to operate their mine, and the kind of equipment they have, and the places they have available on the equipment to mount the Tropos equipment. So one of the top elements of concern in recent years within the mining community, especially the IT and communications community, is field network security. What we found is there's lots of unknowns out there, and I think people are searching for, what are the requirements that I need to think about? And it's a pretty long laundry list, actually, of requirements, and that list will probably grow over time. Everything from network access control to remote endpoint protection, secure data transmission between devices, being able to segment and prioritize traffic across applications. You don't necessarily want to have everybody getting access to everything. You may want to segment your traffic in such a way that you can secure it differently for different applications. The ability to manage the network securely from a remote location, and of course having the ability to audit and have the accountability chain over time from an accounting, from a Sarbanes-Oxley and compliance standpoint. One way that we typically show that model of security, we refer to it as a multi-layer security model. And this is the kind of security model that you see in banking, in military applications, and other applications like that, where you not only secure one element of your architecture, but you secure every element of your architecture, from the physical all the way to the application layer. And there are certain elements, certain ways of doing that that are specific to mining, and actually may be specific based on IT policy of the corporation. Wherever possible, we recommend leveraging standards. The whole idea of security by obscurity is an old concept. It's been shown to be a weak point in many architectures. And from our perspective, leveraging standards wherever possible gives you the benefit of a worldwide security community that's looking for ways of beating those systems and creating patches or creating solutions that evolve over time with the threats. So hackers don't stop hacking. Security models should not stop evolving over time. And the layered security model creates a defense in depth model that says, hey, if you break my application security, I still have 4 or 5 lines of security to avoid you taking over my whole mine. Another way of looking at application security that I mentioned already is differentiated security models based on the type of application. So one of the features that we have in our equipment is the ability to differentiate different services. So we can tie different applications to VLANs and then prioritize that traffic, creating a quality of service structure that typically matches what you would see in an enterprise architecture. The VLANs, of course, extend back into the network and can have different security profiles. You can have different bandwidth requirements for each one of those. So in essence, what you're seeing in the field is those different applications that are being rolled out, from fleet management to safety to SCADA data to mobile operations, can each have their own set of security and bandwidth specifications that can be configured by the IT group to provide the right level of security and the right bandwidth and the right prioritization for their operation. One of the other features that we've seen, kind of going along with that previous slide, is the ability to extend the security model within the enterprise out to the edge. And the IPsec VPN tunnels is one of the ways that our customers have been doing that. Obviously 802.1x for authentication and access control, even out to the vehicles themselves, is being done today within the different mines. Obviously traffic segmentation using VLANs that can extend all the way back not only into the data center, but actually have the ability to extend into multiple data centers. We typically see companies now having a primary data center and a backup data center, or a primary control center and a backup control center, because disasters do happen. And they want to make sure that they have the data that they need and the control they need backed up in case they lose one of their centers for whatever reason. And of course, the ability of having firewalls and the individual endpoints is, I think that's where we're going. What we mean by that is each individual access point, mobile router that is in a vehicle has a firewall in it. So every element of your architecture has a firewall built in, and that's, I think, where we're getting to within the industry from a security model standpoint. People who think that, hey, you know, I'm in a mundane industry, I'm in a not mundane, but, you know, a commodity industry. People aren't going to try to attack me. I'm not a bank. They're not going to steal my money. Industrial espionage and governmental espionage, hey, that stuff is real, and we hear about it every day. A great example of that is how the Stuxnet virus was targeted specifically at Iranian centrifuges to basically target Siemens controllers. That's a great example of how innovative some of these governments or industrial customers, they're getting very sophisticated at the way they're targeting their competition. And so being able to have that defense in depth model, I think, is going to be a requirement going forward. So managing all that infrastructure in a mine. A lot of people look at the distributed architecture, the distributed network, and go, wow, that's going to be a real headache for me to manage. Well, we hear that, and we have responded. I think 8 years ago, we introduced Tropos Control, which is our network management platform. The idea is that this platform is designed for wireless networks, which actually require some unique elements to manage relative to wired networks. The platform is scalable to thousands of devices, and we have performance management capabilities to avoid outages. So in other words, we have the ability to have your IT staff look at alarms, look at historical information. Not only does the mesh itself correct any kind of issues like interference locally and redirect its path to other potential routers to get to the backhaul. That happens without operator intervention. That's one of the beauties of the mesh. But at the same time, being the IT manager, the communications manager, or the SCADA manager, you want to be able to control the network, understand that the security is set up the right way, be able to manage the individual nodes, verify any kind of alarms that may occur, and really do that from a centralized location. You don't want to have to drive around the mine to try to figure out what's wrong. You want to be able to do that from a central location. And you want to be able to do that very quickly so that you can react and send the people where you need to send them at the right time. And so it's a critical element of being able to manage your assets and the IT assets effectively within the mining environment. And we've seen it pay dividends to our customers over and over again. And in many cases, it fits into the standard IT and communications job descriptions that they're already filling within the mine itself to operate the system. So now I'd like to spend a few more minutes, the next 10 minutes, talking about some of our customers. I'll go through 3 little mini case studies and talk a little bit about customers' need, how we responded to them, and then some of the benefits that they've seen. So the first customer is BHP Billiton, which is the Billiton Mitsubishi Alliance. And this is a deployment that's in Australia. As you can see, it's a very large open pit mine. They were in need of enhanced, number one, safety, because as you can see, that's a huge mine. And they were having issues with vehicles being disabled and communications not being able to communicate with the individual, and somebody come around the corner and run into a disabled vehicle, things like that. Or making sure that they can account for all their employees at shift changes and other things like that. In addition, they were looking for enhanced efficiency in terms of their production and operation within the mine. So as part of the solution, we installed fixed and mobile routers throughout the mine. Fixed routers around the edge and in various different locations within the pit itself, as well as on different pieces of equipment. This particular piece of equipment where the photograph is showing, I think, is a dragline, but I'm not exactly positive. But it is mounted on all the drag lines. It's mounted on the haulers. They did solar-powered trailers, tied it into pretty much every moving vehicle within the mine itself. Once they had the network in place, obviously they were able to pull back things like dragline diagnostics, telemetry from the haulers, the trucks, be able to put in GPS within the vehicles themselves so that they had guidance capability or knew where the vehicles were at all times within the mine. In addition, they were doing some productivity monitoring, understanding where the level of production within the mine. So as an example, on rainy days, they were able to pretty well predict based on the speed the vehicles were traveling and within the first hour or two of a shift if they were going to have to move down to a lower quota for the day, or if they were going to have a piece of equipment out of service. They could directly translate a lot of that information into their production for the day and communicate that effectively. So it basically gave the management team, the engineering team, the process team, the operations team great visibility into the way the mine itself was operating and the equipment in that mine was operating to give them a full view of the real-time day-to-day operations. In addition, they could gather a lot of data and take it back do process analysis to improve longer-term processes and efficiency to drive better return on investment. In addition, they put in video cameras throughout the mine with the idea that they could use it as a workforce multiplier and be able to see places in the mine more effectively from a central console from a security and safety standpoint. In addition, they were doing some safety monitoring with man-down systems, and then finally mobile core sample analysis. So instead of having to go back to a lab or back to the control room, they were actually able to do a lot of work on the site at the core analysis. They were able to do a lot of that stuff in the field. It saved a lot of windshield time, which in turn helped drive productivity within the mine itself. The next one, again, is in Australia. It's Fortescue, Fortescue Metals Group, FMGL. Very similar type of situation, but instead of a coal mine, this is a iron mine. They were really looking at efficiency as being one of the things that they were trying to drive within the mine itself. So they, again, put Tropos routers throughout the mine on pump-up masts, the trailers that basically were standalone trailers that had their own power source, and they moved those around as needed within the mining environment as they were basically taking the drag lines through the base of the mine and into different places. They could move the routers themselves out of the way if needed to basically do the dig the way that they needed to. In addition, it went on all the heavy equipment, the excavators, the earth movers, the water trucks, so that they knew where every piece of equipment was, and they could even put mobile video if they needed to in various different places. And by doing that, they also were able to create essentially hot spots around every vehicle. So that allowed handheld devices and other things to tie in into the mobile router that's on the vehicle very cost effectively. That way they could avoid wiring everything. Obviously the customer benefits, number one was the dragline PLC data. So they had logic controllers throughout the dragline. They were able to monitor the draglines remotely, do real-time analysis, be able to make sure that they weren't going to have a predictable failure on the dragline. It basically helped them manage their maintenance schedules and their workforce schedules. In addition, they did fixed video monitoring. Of course, in a mine this size, it made absolute sense to have extra sets of eyes in different places from a security standpoint. They did real-time vehicle monitoring with the whole idea that they were pulling back telemetry data to reduce downtime in the mine itself. So their goal was to avoid having vehicles break down in the mine, number one. But even if they did break down, they could respond and react to them much more quickly by rerouting traffic, by sending the people exactly where they needed to go to do the maintenance, and by analyzing the telemetry data, they could even potentially figure out what it is that broke so that they could carry the parts with them as they went. And then overall operations efficiency improved. Obviously, as you would expect, as they started instrumenting and tying in the data within the mine itself, it gave them the ability to improve processes, improve maintenance schedules and other things in such a way that their productivity increased while cutting some costs at the same time. A U.S. customer that recently deployed a Tropos network was Potash Corp. This one's down in North Carolina, actually, the Aurora mine. Basically, they were going after productivity increases with the goal of minimizing unscheduled maintenance. So they were just looking for improvement of their overall mining productivity wherever possible. We went in with, again, a very similar solution. In this particular case, we focused on the fixed mesh around the perimeter primarily, and the mobile routers on the equipment which were operating within the mine itself. So you can think of it almost like a corral type of model with the vehicles moving around in the middle. And the network itself is pulling back telemetry data, manufacturing process data, and they're also doing voice over IP within the mine itself. So they're using the network for VoIP communications between vehicles and between people operating within the mine itself. Obviously, as you could expect, they are able to, with the system in place and being able to pull back that kind of data, they're able to ensure that the equipment's operating within the parameters so that they have an eye on their operating condition, so that they can recommend taking pieces of equipment out of service, or again, looking at potential unscheduled maintenance activity and being prepared for it in real time. In addition, they were able to, by doing that, they were able to cut down on the unscheduled maintenance within the facility, within the mine itself. And they did a really good job of being able to increase their overall uptime operation of the mine itself. And this particular mine's operating 24/7. It's a continuous operation mine, and they were able to improve the overall uptime and productivity with the mine, and they were able to successfully do that. So, in summary, Tropos provides a very safe and efficient system for operation of the mine. So being able to pull back real-time data, tie in mobile communications to different devices in the field, and having the ruggedness and hardened equipment to survive the ongoing 24/7 operations of many mines around the world. Being able to tie in fleet asset management, fleet management applications, mining management software, real-time telemetry and video really are enhancements to productivity and safety within the mine. And to make that work, you really have to have a very stringent network performance capability within the mine. You have to have that out of the gate to be able to provide very high bandwidth, very low latency, very high availability. You don't want dead space. You don't want to have lack of communications for any amount of time. And of course, you want to have the enterprise level security and the mobility, which I think goes without saying in these mining environments. And we have a lot of mining customers that we can point to that are seeing huge benefits. Brand name customers. This is not a niche application, and we see it growing as the mining market has to be more efficient at their operations as commodity prices have dropped. Basically, they have to become more efficient to be profitable. And investing in these types of systems is one way that we see mines, getting a return on that investment in a big way. So with that, I think that's the end of my presentation, and we can open up for questions. I actually have a question. I'm going to go back and not leave it on this slide. I actually have a question here. Let's see. Do you have real ROI numbers from some of the deployments that we've done with customers that we can share? So as you would expect, we do have some numbers, and they vary depending on the size of the mine and the type of mining they're doing and the applications they're running. I don't think I'm at liberty to give out specific information because most of the customers don't like us sharing that type of info. But I can kind of give you some general numbers and not tell you who they're from. So as an example, with one particular mining company, and I think this is a great example, this is actually in South America, we had gone in with the mining company, and they put in a mining fleet management system along with a wireless mesh network within their mine. And within a 2-year period, they cut their maintenance budget down to only 5% of their overall budget. And prior to that, it was well over 20% of their overall mine budget. So they went from a 20-something% maintenance budget down to about a 5% maintenance budget per year. And that's over a 2-year period. And at the same time, they actually increased productivity over 40% within the mine. So they increased productivity by 40% while cutting their maintenance budget during that same time frame. And pretty much they attributed it to the ability of real-time analysis, process analysis, maintenance, being able to optimize their maintenance models, some of the things that we've already talked about on this call, and of course the real-time wireless communications is a critical enabler of doing those types of applications. And we see similar numbers from different mines around the world. I mean, sometimes where mines already have some systems in place, the change may not be quite that dramatic, but we do see significant return on investment from investment in these types of systems. Okay. Let's see. Next question.
Rob, it's Lisa here. There's a question from the audience. Do you have any experience in underground mining applications of your technology?
So, yes, that's a great question. So I talked about open pit. We have a lot of experience in the open pit mine. We have a little experience, and we're starting to have more experience in underground. So now that we've become part of ABB, we've had the door opened for us to go into a wider range of customers, some of which are already existing ABB customers. And so what we've done is we've done some pretty robust, I would call it testing. It's more like a pilot within the underground environment in the past year, not quite year, past 9 months. And from what we've seen, we were, number one, very surprised and impressed with the performance. The equipment's performance in the mine actually exceeded our expectations for what it would do in an underground environment. So they had a problem where they were using another vendor's wireless 802.11 communications, but because of the architecture that they used, vehicles moving through the tunnels in the mine were causing interference and were causing signal blockage. And so essentially they put us in such a way that they tied us into fiber going down through the ventilation shafts and the control shafts within the mine. And at the different levels of the mine, they then leveraged meshing within the tunnels. And they found that by putting our mobile routers on the vehicles themselves, surprisingly, the vehicles basically became a repeater for the signal through the tunnel. So that was really great. And so we have limited exposure. However, that being said, that probably within the next 6 months, you will see we'll probably have our first set of production deployments in an underground environment going forward. So it's an area that we're growing into. We have a lot more experience in the outdoors, in the open pit space, but I would say that within 18 months, we'll have a couple of good customers that we can talk about in the underground space. Okay. So I had another question asked regarding difference between mesh and a Wi-Fi access point. So, so that's actually a good question. We've run into that question before. They're like, okay, well, our mine has some access points deployed. You know, what's the big difference? Well, number one, the meshing architecture doesn't. An AP typically relies on some sort of a backhaul connection to every device, a network backhaul connection to every device. And that has to be put in either via an Ethernet cable or a fiber cable with an Ethernet converter on it, or has to be tied in through a point-to-multipoint system in some way. So every point has to have a backhaul. If you have a failure or you have interference, there's pretty much an outage or no alternative, because the signal doesn't have the ability to go anywhere other than back up to the control location, whether it's a base station or a controller. So it's really a star topology more than anything. The meshing architecture is a lot more dynamic. You have distributed intelligence, and not every access point has to have a wire or a backhaul connection attached to it. And in fact, in the mining example that I showed, it was a real mine layout. About 1 out of every 10 Tropos nodes deployed in that mine had a backhaul connection of some sort. So it really reduces the overall cost. It takes it from a star topology into a meshing architecture which allows data to flow back up through one of many backhaul connections, whether it's through a wired Ethernet backhaul connection or through a point-to-multipoint link. If you have a link failure on the point-to-multipoint system, the mesh system reconfigures and takes advantage of the other point-to-multipoint backhaul links to get the data back. So it's a much more reliable architecture. In addition, our meshing architecture does full mobility, which is unique. Each individual mobile router is also an access point, is a hotspot within the vehicle. And so that's actually a little bit different than some of our competitors. Those are really the two big key differences that we see. And it goes back to being more reliable and also easier to maintain and operate. Sorry. Any other questions? I think we're 5 minutes to the end of the hour here.
No, there's none that I have waiting, Rob.
Okay. Well, with that, I think we're done. So I wanted to thank Corinne and the team from Alliance for putting this webinar on. I appreciate the time and getting the chance to speak to everybody. And if there's any follow-up questions, we're happy to answer them after the fact. So thanks again for joining, and have a great day.
Thank you, Rob. Great presentation.
Thanks, Rob.
Thank you.